The next one looks at whether or not something is a strong or weak acid, or a strong or a weak base. All right, now, there are 4 of them, but we're going to add a few, okay? This is very similar to, doesn't it feel like I just did this problem? Yeah? So we'll say A, B, C, D, E, F, G. Okay, now, let's see, NaOH. All right, what is B? NH3. C is H2SO4. Is that right? And what's D? HCl. We'll say E is HC2H3O2. We'll say that F is NH4 plus. We'll say that G is H2CO3. Okay? Is that good? Yes? All right. We'll spend a few minutes on this one. All right, so NaOH, strong or weak? Oh, by the way, what does it mean, strong or weak base? What does that mean?
Completely dissociated.
I like that. Completely dissociated. I like that. Excellent. Completely dissociated. Not completely dissolved? Is that the same thing? Completely soluble? Does that say the same thing? Does it? Does it? I'm asking you. Is sugar completely dissolved?
Yeah,
It is? Is it completely dissociated? No. So being completely dissolved does not necessarily mean being completely dissociated, does it? No, it doesn't. Right. Isn't ammonia gas extremely soluble in water? Isn't it? Is it a strong base? I'm kind of giving it away here. No, it's a weak base. Okay. So, all the sodium salts, sodium hydroxide, they are completely dissociated. Yes? Strong base or strong acid? Strong base. Strong base. S for strong, B for base. Good? All right? Ammonia. Memorize it if you have to. Strong or weak base, acid, what? A weak base. How about sulfuric acid? Just the name to me is scary. Very scary. If I were king, I wouldn't allow sulfuric acid in a high school science department. I just think it's unnecessary. Very strong. Very strong what? Acid or base? Strong acid. How about HCl? Very strong. How about, what is that? HC2O3, HO2, what is that? What is it? Shall I draw it out for you? Looks like this. Same thing. What is that? Any idea? No? I'll give you a hint. You put it on salad.
Salt.
Salt? Really? Really? You want to go there? That's salt?
No, that's not salt.
That's not salt, no. Anybody?
Put on what?
Salad.
Your salad.
Oh, citric acid.
It's what?
Citric acid.
Citric acid? You put citric acid on your, well, some people do, I guess. Lemon juice. Yeah, could be. What is it?
Vinegar.
What's vinegar? What's the active ingredient in vinegar? What vinegar is a dilute solution of this. Ethanoic? Yeah, that's a very serious name for it. Ethanoic acid. Ethanoic acid, that's right. Ethanoic, ethane, 2 carbons, ethane, 2 carbons, right? Good. oic, meaning the carboxyl group. Yes? What's the common name for it? No? Nobody knows? What is that?
Acidic.
Acetic acid. That's the common name. Acetic acid. It's what's in vinegar. Okay? Or ethanoic. Okay, good. Strong or weak, acid, base, what? Is it going to give up this? Or is it going to give up this? Is it a base or an acid? Excellent question. Excellent question. Is it a base or is it an acid? Is it going to give up hydroxide or is it going to give up hydrogen?
Hydrogen.
Yeah, it's an acid. Is it a strong acid or a weak acid? Yeah, you couldn't even make up your mind whether or not it was going to give up hydroxide or H. So what your intuition is pretty good, actually. It's working overtime today. So it's actually a weak acid. Would you say that, Laura? Yeah, it is a weak acid. It is. And what makes it an acid at all is this. Is this double bond. It kind of acts as a sucking device. Sucks the electrons up. Actually weakens that bond so the hydrogen can fall off. It's true. Because if I got rid of that double bond O, what would I have? What would I have? I'd have this, right? I'd have that. Is that an acid? You know, anybody know? What is that, an acid or a base? It's neither. Alcohol. What kind of alcohol is that? Ethyl alcohol. That's the stuff in booze. People actually drink that crap. Can you imagine? It's true. Amazing, really, if you think about it. Very poisonous. Okay? Ethyl alcohol. If I put a double bond on here, I drive the electrons this way, and I weaken that bond. You see how that works? Yeah, you see that? Makes it to an acid. So acetic acid is going to be a weak acid. It's going to be a weak acid. How about ammonium? Ammonium. Think Brownstedt-Lowry. Brownstedt-Lowry. Anybody? You have not been watching the videos that I've been making. Some of which I made in here. It's going to be a base? Well, let's see. How do I make it? I make it like this. I make it like that. Okay? I make it like that. I'm in the middle of filming, guys. Whose is this?
Catherine Minor.
Is Ona here?
No,
All right, tell her I need to see her as soon as she gets here.
she's not coming today.
Doesn't she have a test?
No,
Ona doesn't have one?
not today.
Okay, could you get her on the phone right now and I'll talk to her? Okay, now, so this is how I make it, right? Yes? This is how I make it. So what is this? Yeah, this is going to be a proton acceptor, isn't it? A proton acceptor, according to Brownstedt-Lowry, is what? A proton acceptor is a what? Is a base or an acid? Is a base. You got to do some reading, guys. You got to read. So the conjugate acid would be a proton donor or acceptor. Do you think that's going to donate an electron or accept another one? Do you think it's going to accept a proton, another proton, or is it going to donate a proton? What is it? It's going to donate or accept? It's gonna accept another one? So why doesn't it just keep accepting? What is it, the universal perpetual proton acceptor? NH5, NH6, what? Or do you think that it's going to, donate a proton? It's going to donate. This is an acid. If that's a weak base, what do you think that is? Nope. It's a weak acid. And what's this one? Weak acid. Know this problem. Are we off? You've got to look at these videos, guys. I can tell you right now, you're not doing it. You're not doing it. I've spent a lot of time on these problems. Okay, enough said.